First of all, thanks very much for your kind invitation. And well, I was invited to show you something that is simply a project and not yet something clinically real. And is mainly related with the iris claw concept. You know, or possibly some of you know, that I've been defending this phakic implantation because of several reasons, but mostly because it's centration. We are responsible for this centration, and this is something important in front of other symmetrical lenses such as angle supported or sulcus supported lenses, where the lens is centered in the eye and not on the pupil. So you can centrate this lens on the pupil or whatever you think it's better to centrate. So this is an advantage. Also fixation, that's important for any vectorial correction, and also for some other advantages. This platform comes back from the late 70s, and initially it was a PMMA platform, initially just for the phakic correction. It was in the 90s that we started using this implant for phakic corrections, for ametropia correction. And the ArtiFlex appeared in the early 2000s, and the ArtiFlex started in 2003, and which is the one that you have on your left. But now the new project is the hydrophilic ArtiFlex. It's equal conceptually than the original ArtiFlex, but has some significant differences. This platform, this new platform, because up to now ArtiFlex has been only able to correct myopia and myopic astigmatism, but this new platform will be able to be used to correct myopia, hyperopia, aphakia, and hopefully also presbyopia. It's an aberration-free optic with neutral asphericity, which has some advantages from an increased depth of focus point of view, and some other characteristics. I would like to review it as quick as possible, but the company has changed a little bit, although the number of cases with glare and halos is extremely low with the actual ArtiFlex. Well, they have improved logically the edge of the optic and the attachment with the haptic, so theoretically improving this phenomenon that some patients have. Is smaller than the original. I will not bother you too much with the video because I'm pretty sure that you have seen this implantation, so let's go relatively quick. So basically you will be able to introduce this lens. Instead of doing this, because you need to have today a 3.1 or 3.2 incision, because the actual PMMA haptics has a 3 millimeters length, so you need a little bit more to get the lens inside the eye. And this is the instrument that today we are using, squeezing the lens through the incision. So instead of doing this mechanism later on, basically the rest of the steps will be the same. Will be this one, and you can use either the needle or the vacuum fix, as in this case. So basically, the surgical behavior will be the same, but with some differences. You will not use this squeezing maneuver, but you will use a injector. So it will be inside the injector when the company provides the lens to you. So you will be able to introduce with 2.5 incision because the length of the haptic is a little bit smaller than the actual one. Also, the shape, the posterior shape of the lens is slightly more convex, especially in the peripheral part. So the possibility of having giant cells growing over the posterior surface, which in some cases today is still a problem, will theoretically diminish. And also, because of this new shape, there has been some studies for both, you can see on the left side, for both the ICL, on the right side, for both the ICL and the ArtiFlex. There will be theoretically enough with the pupillary movements, enough fluid coming around the lens to escape from the need of an iridectomy. Although I personally think that at least I will continue doing iridectomy as long as I implant this lens in a phakic eye. The toric version will have the improvements that some other optics from Optech has had during this last couple of years. This new toric profile has some obvious advantages demonstrated for the precision lens regarding small rotations. So this new design for toric optics accepts much more a slide 10 or 15 rotation than other lenses. And this is the project for the presbyopia correction, which will be the same kind of optic for both the pseudophakic lens, the one for the precision lens, the precision platform, and also for the new ArtiLens. It's working basically on the basis of a alternating optical zones, selective near-far distribution, as you can see in this diagram. The first trials with the pseudophakic lens are just starting, and as you can see, this is a convex lens with a 50-50 distribution, but in a kind of trifocality, as you can see here. And at least, not yet on humans, but on the bench, this also has been studied at the UPC, at the Polytechnic University of Catalonia in Terrassa, and they have been evaluating on the bench with obvious advantages, as you can see in this diagram, not basically on optical quality. So for both the MTF for distance and near vision is clearly superior than any of the actual existing presbyopic lenses. This is a bench advantage. Let's see if clinically makes any sense or not. Anyway, the same system will be ready later on. I presume that this will be at mid next year, so at mid 2016, with the same optic, but for a phakic lens. It can be used as a phakic implant in a presbyopic individual, or as a secondary implantation in a previously operated eye, which is already pseudophakic with monofocal lenses. And the clinical studies I mentioned will come in about 6 months. We will start with the aphakic lens, then the phakic lens, and then the presbyopic lens, so I presume that it will not be before mid-2016. Thanks very much for your attention.